Alright guys, in this video I'm going to go over how to deal with radicals and rational exponents. So these are the problems that you should be able to answer by the end of this video. So first thing I'm going to talk about is I'm just going to show how to go from one to the other. When I have a radical, there are three parts that I need to think of. The radicand, that's the part on the inside. The index, that's the little number that's right here. If there's nothing there, it's an implied 2. And then the exponent. So when I'm looking at this, I'm gonna write it as I root r to the e. When I want to write this as exponential form, all that really means is write it with an exponent instead of a radical. And the way that we're going to do it is the radicand stays the same. The exponent goes on the numerator of a fraction, and the index goes on the denominator of a fraction. So if I have something like the square root of 3, this 3 has an implied 1 right here, and a square root has an implied 2 right here. So this becomes 3 to the power of 1/2. If I have something like the fourth root of x to the 2, that's going to become x to the 2 over 4. So whatever the exponent is here goes on the numerator, whatever the index is here goes on the denominator. This one I can actually simplify. I would simplify that to x to the 1/2. So that's what we're trying to do when we're going that way. If we're going the other way, we're going to use the same sort of rules. So I'm going to have the radicand, the exponent, and the index, and I'm going to make it into the index, the radicand, and the exponent. So if I have something like x to the 1/3, it's going to become the root, third root, because that comes right here, x to the 1, which of course I don't need to write the 1, so it's going to be the cube root of x. If I have different exponents right here, like different denominators on my exponents, I need to get a common denominator. So I can't put this in the same radical because this one's a cube root and this one's a square root. But I can turn both of these into 6 roots. So this is going to be 2/6, and this is going to be 3/6. So now I can make it a 6th root of x squared y to the 3rd. So sometimes I have to get my my rational exponents the same, and rational just means that it's a fraction. So I have to get it the same denominator to be able to do it. Okay. Now we're gonna also rationalize denominators, which really what that means is we're trying to get the radicals out of the denominator of a fraction. So if I have something like 3 over the square root of x, I don't want this to have a square root, so I'm going to multiply it by itself, which means I have to multiply the numerator by that same thing. I can only always multiply an expression by a variation of 1, so whatever it is over itself. And that's going to become 3 root x over x. Now I think personally an easier way to think of this is that this is x to the 1/2. If I multiply by the same base, I'm adding exponents. So what do I add to 1/2 to get 1? I add 1/2. Since I multiplied the denominator by that, I have to multiply the numerator by that. So I get 3x to the 1/2 over x to the 1. X to the 1/2 is really just the square root of x. So that's the way I like to think of it. The reason that I like to think of it that way is just because when I have something like this, I'm not just multiplying it by itself like I did with the square root. I'm multiplying it by what adds to this to give me 1. So what do I add to 2/3 to get 1? Well, I need to add 1/3. What do I add to 1/4 to get 1? Well, I need to add 3/4. Whatever I multiply my denominator by, I also have to multiply the numerator by. So this is going to be the cube root of x. So I have 3 cube root of x, and this is going to be the fourth root of y cubed. Fourth root of y cubed over xy. This is really ugly, so I'd prefer to have a common denominator like I talked about a minute ago. So instead of doing this, I'm going to find a common denominator for 3 and 4. 3 and 4 is going to be 12. So that's going to be 4 twelfths, and that's going to be 9 twelfths. So I multiplied that by 3, I multiplied that by 3, gives me 9 twelfths. Multiplied that by 4, and multiplied that by 4, gives me 4 twelfths. So really what I want to write it as is 3 12th root of x to the 4, y to the 9 over xy. Hopefully that makes sense. We'll do a little bit more in class.